Okay, guys. So, في شغلة كمان that we can do is, kind of to simplify, you having to introduce X, right? One thing you can do is you can just, find the acceleration that would cause it to slip, and then you just, write it somewhere, and then you find the acceleration that would cause it to tip. And then at tipping, we know N is going to be here, so you just ignore N, but you sum the moments about that point, and then you can solve for the acceleration for tipping. Does it make sense, guys? So هيك basically we can.
Homework قالوا if it's less than 0.3 then it slips.
Yes, فيك تعتبر. So yes, you can. So there are multiple ways of looking at this problem, right? So I think what we should do here, like probably the easiest way for you guys would be is just find the acceleration that it would cause at the verge of slipping. اللي هي لقيناها قبل. Right, so we can find this acceleration at the verge of slipping. You guys agree? Right, and you can find another acceleration which would cause this guy to tip. How do you find the acceleration when this guy is about to tip?
You take the normal at O.
Exactly, just take the normal at O, and then you can find the acceleration at tipping. All right, and now you have two accelerations, and then you can see which one is bigger, right? If the acceleration for tipping.
Doctor.
Yes.
بس وقت الان تكون بين يعني بتكون مثلا حسب 0.2 يعني كلها عملت سليب لا لانه الان المفروض تبقى على center of gravity لا
if you mean the distance, no, this is unrelated. So basically here, if x is equal to 0.2, essentially you are solving for the moment arm that is making this guy balanced, right, for a given acceleration. And for a given acceleration, right, as you increase the acceleration, basically the location for n will actually change to balance the moment for the acceleration.
اوكي بس لانه كنت عم جرب افهم لانه اللي قاله مارون.
Yes, so this is exactly what is happening, guys, here, right? So what I said is here, if you look at the moments for this guy, right, here this x, right, n times x, that moment here is actually increasing in response to ma. So if you are increasing ma, right, the moment r for mg is fixed, right? So the friction is not creating any moment. So the moment arm that is created by n, right, n times x, is actually used to balance the moment for ma, right? And if x is, if x is 0, it means that basically the moment arm here is basically becoming here basically, and then that guy could be on the verge of tipping, right? This is one way to look at it, right? But the other way that we have been teaching in the course is you solve for two different accelerations. First acceleration you solve for is the acceleration that would cause this guy to slip. And in that case, F is equal to mu s times n. And it doesn't really matter where that is because you're only solving for the forces in the vertical and then the forces in the horizontal. So we can solve for the acceleration that would cause this guy to slip. And then we can solve for another acceleration for this guy to tip about 0.0. And we sum the moments about 0.0. Here we assume x is equal to 0, assume n is here. And then we can solve for the acceleration at tipping, right? And then you can use the smallest acceleration of these. Okay, guys, so enough said about this problem. I would recommend that you guys solve it on your own if you don't understand it now. And if you still actually have questions on it, I'd be more than happy to, to also solve it for you one more time. By one-on-one, for example, or something.
بس دكتور yes. بس شغلة صغيرة. Okay, if we solve first يعني we get A for slipping, we get A for tipping. أصغر واحدة بتكون اللي بيصير بالأول يعني.
Yeah, exactly. So let's say you get the acceleration for tipping, right? And then let's say you also have the acceleration for slipping, right? And then you solve for those, and if the acceleration for slipping is greater, can you tell me what do you think is going to happen?
So it's going to slip before it's going to tip, هيك يعني.
Exactly. Yes, it's going
okay.
to right. It's going to tip. Right, as the acceleration for slipping is greater than acceleration for tipping, it's going to tip before it slips. ما هيك ليه؟ لأنه you know let's
هيك
say this
قصدي.
is your acceleration here, right? So the acceleration for tipping is here.
Because doctor, in this question, they aren't asking which one is before. They just ask the smallest acceleration that will cause it to either to tip or to slip. So we
this
just
is
need to.
exactly. We just need the smallest one, right? We don't need the higher
Yes.
one.
No,
So
we don't
basically,
care
let's say
if
this is acceleration. Exactly, we don't care exactly. So now we're solving the problem in a little bit more advanced way. So let's say this is your acceleration value, right? So let's say if it's gonna, you know, you're increasing you're applying that force, right? And the force is directly associated with an acceleration. Because هون ما في عندنا rotation or the acceleration is directly related to the force. So if the force basically, if the acceleration increases, the tipping acceleration is gonna begin to tip. It won't slip. Right? So let's say you have that physical system أنت عم تمشيها, let's say, right? And then you try to pull on it, it will never slide, right? You will never actually see it sliding because it will tip before it slips. Does it make sense? Because again, the opposite way, then if you try to pull on it, it will never actually tip before it slips. So you will never see it tipping because it will always be, you know, kind of slipping and then dragging on the floor. Does that make sense?
وإذا الديسلريتنج بتعمل سليب قبل أو تعمل الأكبر قبل.
As a decelerating, then it would be different, right? Because now you're going to consider the moment in the other direction, right? And maybe the moment arm will actually change based on that, based on the dimensions. And عندك الانجل, basically, I think some of the stuff will actually change in the deceleration direction. But then just know what we just discussed, okay? And then you know, kind of you know, dwell it in your mind, and then you guys should solve this problem on your own after my session, and I think you will be able to fully understand what we mean by this. Okay, guys, back to two problems that I think are very important that we solve. One of the problem is actually the bowling ball, right? Let's say you have a bowling ball, right? Which is basically like a cylinder, right? And you know, basically when you are throwing, let's say, you know, this is a floor, right? And the ball basically is being thrown with just some velocity v0. You guys agree? And initially omega is actually 0. It has no acceleration over here. Can you guys tell me how do you solve for, let's say, the distance, right, that the bowling ball will travel as soon as, let's say, it's actually hitting the floor here, right? What is the distance that it travels when for it to actually catch on, and then it will be rolling but not slipping? Right, let's say I tell you that you have here mu k and then you have us. How do you solve this problem, right? So you threw the ball, let's say it has moment of inertia ig, it has a mass m, and obviously g is acting downward. This is a problem in your homework assignments.
دكتور ما فهمت كيف ما فهمت البروبلم. هي كانت عالية عن الأرض.
Yeah, so you have a ball, right? You push the ball with a velocity v0. So you give it an initial velocity of v0, all right? And now it's gonna be, you know, like what I mean by this is initially it was above the floor, but the movement basically will be you're at the floor, right? So let's say, you know, this guy is now touching, right? It touched the wall basically. Now it's kind of you know, moving on the wall, right? So you threw the ball. It has an initial velocity v0, but it had no rotation, right? And now I want to see how long it's going to be traveling. So when, you know, when the ball basically is touching this, it may be, you know, sliding and then rolling at the same time, right? Sliding and then translating, right?
Yes.
I want to know
if it's sliding and يعني if it's rolling and translating at the same time هذا يعني عم تعمل slip أو ما ضروري.
Exactly. It would be rolling here, so it's slipping basically all its duration, right? Here it would be slipping. You guys agree? And then here, right, at some point D, basically the ball is going to be basically just kind of rolling, right? Rolling but no slip, right? So after some time T, the ball will basically roll but not slip, don't slip. Roll without slip. Okay, so how would you solve that distance d?
We can say that the friction at the beginning is, we use mu k because we know that it's moving because of the velocity.
Exactly, right. So initially we know it's slipping, right? We have to do a free body diagram on it, right? So I know I'm going to have mg and I'm going to have n, right? And what is the friction over here? Well, initially the friction is going to be definitely mu k times n.
UK.
Right? Because the ball here is slipping, right? And then what am I going to have on this figure? Can someone tell me?
MAG to the right.
To the right or to the left?
Not to the right.
Left.
Oh, to the left because of the force.
It's decelerating.
You only have one force, right? To the left. So
Yeah.
you're going to have one force, right? So you don't have MAG like that, right? What else are you going to have?
IG alpha.
IG alpha.
How does IG alpha look like in this case?
Clockwise.
Clockwise.
Okay, so IG alpha is going to be like that. Why? Because we said you only need to sum the moments about 1 point to prove the direction of our alpha. Okay? And basically, if you sum the moments about this point, right, then these are the only moments that you have, right? And this guy will give you this alpha rotation. All right? Okay, because that is the force, right? If you sum the moments about this point, this guy obviously is not creating any rotation. Mu k times n is going to give you that rotation like that, right? Which is in the direction. Okay, very good. So can I actually, what is AG? Can someone tell me what is AG in that case? How can I find what AG is?
It's mu k n over m.
Okay, we can sub the forces. I'm going to have what? MAG, is equal to mu k times n, which is mu k times mg. So AG will be equal to mu k times g. Right? Does that make sense? Right? It's very simple, right? So AG will be equal to mu k times g. Now, what is alpha? How can I find alpha? I think the easiest way would be to sum the torque moments about 0.0, and then I can relate AG with alpha, right? So if I sum the moments about 0.0, I'm gonna end up with what? IG alpha, right? Minus, you guys agree, right? So if MAG is in that direction, so this guy is positive, then this guy is gonna be negative, minus MAG, multiplied by R.
The radius. Yes.
Is going to be equal to 0, right? So here, now, I know what AG, I can actually solve for alpha. So alpha is going to be equal to MAG R over I, and AG is equal to mu k times G. So M mu k G R over I. Okay, is that clear, guys?
But doctor,
Yes.
when it's sliding, isn't the friction pushing it to the right? Because it's slipping?
No. So basically, you threw the ball, right? So the ball is going in this direction. We know friction is going to oppose the motion. Initially, it is sliding, right? So we know the friction definitely has to be, asperity contact. Basically, you have only, kinetic friction, which is mu k times n. Oops. Right, so the friction here cannot be pushing this guy to the right, right? If friction was pushing this guy to the right, you're going to have MAG to the right. It means that it actually will accelerate even more, right? But once you actually throw the bowling ball, as soon as it actually hit the ground, basically it's going to be decelerating as a result of this mu k times n, right? It's never possible that you have an object on the ground and it's accelerating on its own. Whether it is rolling, have you ever threw a wheel and the wheel will accelerate on its own? Unless it's obviously going downhill, right? Where you have a moment due to you have mg sine theta or whatever, right? It's impossible if you're going on a horizontal terrain that you're adding more accelerations, right? So here you throw it to the right, friction is going to be dissolved. Okay, so now we solve for alpha, right? How can I continue that problem from here? So, I have alpha, and now notice alpha is what? Is constant, okay? So your angular acceleration is constant. So when you throw the bowling ball, initially it's not rotating, but as soon as it actually catches the ground, it's going to start to kind of rotate slowly and then slowly, right? And then ultimately it's going to be spinning very fast. And the reason why it's going to be spinning very fast is that if the angular acceleration is actually accelerating with this angular acceleration. So how can I get? How can I continue and solve this problem more?
We can say that V equal omega r and omega equal alpha t plus omega 0. And
Okay.
we relate V with alpha and t.
Wait, so we said V is equal to omega r. Can I actually say V is equal to omega r?
If it's not sliding,
لا
yes.
في slipping.
Exactly, when it stops, right? Slipping, right? Which basically occurs here at the end. Okay, and then let's actually call that time t1. So the velocity هون, so initially it had v0, right? And then here, basically you're gonna have, when it will stop slipping, your velocity will be equal to v1, and v1 here will be equal to omega times r, where r is the radius of the bowling ball. You guys agree? Right? So how can I, so let's actually do that. So we're gonna call this guy v1, and then omega 1. Omega 1 is at state 1, right? Which is at that time t1 here. So you guys can see it. How can I actually get v1, by the way? I have v0. How can I get v1?
V1 equal AT plus V0.
Exactly. So I can say v1 ما هيك لأنه هون linear acceleration applies, right? So v1 is equal to v0, right? Minus what? Minus ag times t, right?
AGT.
Times t1 ما هيك, which is equal to how much? v0 minus mu kg multiplied by t1, right? And how can I get omega 1?
Omega 1 equal alpha t plus omega 0.
Exactly. What is omega 0?
0.
0, exactly. So omega 1 will simply be alpha 1 multiplied by t1. And why I have alpha 1 is because I know omega 1 is going to basically be in the same direction as alpha 1. Okay? It's not decelerating, but here the velocity is actually decelerating. So omega 1 is going to be equal to m times mu k g r t1 over I. So how can I solve for the time t1?
Plus omega 0.
There is no omega 0 because when you throw the bowling ball initially, it had no rotation, right?
Okay.
It didn't have any rotation initially. So how can I solve for the time t1?
We should have omega.
Well, we have omega 1, okay? So we have this guy. So I think if you actually use this equation, okay, if you use this equation, you will actually be able to solve for t1, right? You can replace v1 by its value, and then we can replace omega 1 by its value, right? And then we can actually solve for the time. And once we solve for the time, we can actually get the distance, right? So I'm going to rewrite that. So I have v1 is equal to omega 1 times r. I know v1 is equal to v0 minus mu k g times t1. And I know omega 1 is going to be equal to m times mu k g r t1 over I, right? And here, guys, what is omega 1? Omega 1 is increasing with alpha, okay? So we have alpha applied on this guy. It's, as soon as the ball hits the ground, it's going to have an angular acceleration, and the angular acceleration is going to build up rotational speed on the rigid body, right? So all you do here is that you're going to say, just apply that equation. So this condition will apply when the ball is rolling but not slipping. Vk gt1 is equal to omega 1 times t1, right? So omega 1, which is equal to m mu k g over I multiplied by r. So I'm just going to put r squared over here. So if I multiply by I, I'm going to have v0 multiplied by I is going to be equal to mu k g times I plus m u k g r squared times t1. So here you have just solved for the time that it takes for the bowling ball to catches on, and then it will be rolling UK G R square, right? And then perhaps we can even write like that, right? UK G I plus MR square. Is the units proper, do you guys think, or no? I divide by I plus MR square. This is unitless, okay? I divide by I plus MR square. V0, UK is unitless, so V is equal to kind of, you know, times G, right? So V is equal to T times acceleration. So, you know, the units will be in seconds for sure. So this is one way to kind of just double check that, you know, what you worked on. So we solved for the time. How can I get the actual distance?
S equal half AT squared plus V.
Exactly. So the distance is going to be equal 1/2 AT squared, right? Minus V0T or what? Minus, minus V0T, right? And then that's T1. So S is going to be equal to 1/2. We know A is going to be equal to mu kg T1 squared minus. And you know what is interesting here is that we actually never actually use it at US, right? So we only used UK. Okay, guys. So is that clear? You know how we're solving these types of problems.
Yes.
Okay, guys. So we're gonna solve one last problem, and that would be it regarding our problem session, because you actually have another tutoring session at 12. So you can also ask the tutor as well more questions if you guys have. So I'm gonna actually solve one of the problems that we have on our in the slides, and this is actually this problem. So we have something that looks like that. So we have a pulley over here, and we actually have a disc, and this guy is connected over. There's another pulley over here, and then this guy is kind of fixed like that. And this is block B. This is block A. Gravity acts downward. And what they ask you is that find the least mu s, right? So this guy, you have mu s here. Find the smallest coefficient of friction so that this guy rolls, but it doesn't slip, right? How can we do that? G, and then it has a radius R. G, and it has a mass M. Okay, how can you solve this problem? So the first thing that you have to do here is what?
Free body diagram.
Exactly, free body diagrams. Always, right? So how does the free body diagram look like on this guy? So we have a tension T applied, right? So we have a tension. Okay, we have a normal force, and then we have the weight. What else do I have? I have a friction, right? So the friction here is, let us actually keep the friction F, just so we can, kind of, count our unknowns, and then see what happens. On the right side, what do I have? I'm going to have M, right? AG1, right? And if this guy is moving to the right, we are going to have IG multiplied by alpha 1, right? How about on this block? So I have T here and then T here. So I have two T's, right? So I have 2T applied. And then I have MB, right? G. Let's actually call MA here. And then this guy is MA. NBG. And then what do I have in terms of the accelerations? Let us actually relate the acceleration of B with acceleration of G1. This guy is going to be equal to how much? How do I draw this acceleration right now to relate it over to AG1? So AG1 is going, AG1 is the acceleration of this point G1 right here, and then it's actually going on to the right. How do you get the acceleration of that point G1 over to B?
The acceleration is the same on the row, and it's half the acceleration if
Yes,
it's double
it's
the
half.
tension.
It is half of that, or is it twice of that? So this acceleration downward, is it half of this or twice?
Half.
Half, exactly, right? Half. So I can simply write it MB AG1 over 2. Now this guy, if this guy moves a little bit, this guy is going to move a lot, right? More, exactly, right? Okay, very good. So what we'll do is, how many unknowns do I have? Can someone tell me what are the unknowns?
3 unknowns.
The tension and
Tension.
AG, normal and
Alpha.
friction. Alpha.
Oh, okay. I know.
And then alpha, okay? Alpha 1, right? So we have 4. How many equations do I have?
I have 2 on the first body, and then 1 on the block B.
But we have 4 unknowns. لحظة. What else did we forget? We forgot F, right? Forgot the friction. So we have how many equations do I have here? How many?
3.
Exactly 3, guys. A rigid body will always have, you know, in general, like when you have forces in the X and then the Y, it means you have 3, okay? Summing the forces in the X, summing the forces in the Y, and then summing the moments. So we have 3 here. How many we have here? 1, okay? Summing the forces in the vertical direction, right? And then we need 1 more equation. So, you know, the dynamic equations, we have 4, right? In terms of summing the forces and then summing the torques. We are missing 1 more equation, which is what?
Kinematics.
Exactly, which is what? AG is equal to alpha, AG1 is equal to alpha 1 times R, okay? So we can get the force equation. So when a system is rolling but not slipping, right, it means that we can always solve for the value for the friction force, okay? This is what we had said last time, and then we're going to say it one more time. So now, if you release that, if that disk is rolling, right, but not slipping, it means that you are actually able to solve for the value for the friction force. And then you can test if it's slipping or not slipping, right? In our problem, basically, they ask us for the least value for the static coefficient. So Hone, based on the equations that we have, it means that we'll actually solve for the force. Okay? We don't need to use F is equal to mu S times N. So we need to solve for the value for the force. So let's say you got F is equal to, you know, F0, right? If they ask you for the least value for the coefficient of friction, right, so that this guy rolls without slipping, it means that they're simply telling you that we can actually make mu S times N. So we're finding the value for mu S, right? And then we're setting that value is equal to F0 time, you know, we're making that guy is equal to you know, kind of F0 over N, okay? So we're solving for the value of the coefficient of friction based on F0 and then N. Does it make sense, guys? So we mean basically here we're at the value at the verge of slipping, right? And at the verge of slipping, we know F0 is going to be equal to mu S times N, and then we can simply solve for the value for mu S. Okay, that would be essentially the least value for mu S. To recap, guys, so based on what we have here, we can solve, based on these unknowns, we can solve all of them, right? Including the value for the friction force, because this disk is rolling but not slipping. So we can actually solve for the value for the friction force. And once you have the value for the friction force, you can calculate your static coefficient of friction, right, based on this value for the friction force. So the value for, you know, mu S has to be equal to F0 ultimately over N. Okay, guys, so this is what we have to do. So how do we solve for these values? So we're gonna draw basically free body diagrams, and let us actually do it very quickly. So we can begin on the disk, right? We can sum the forces in x direction, and you are going to end up with what? So T minus F is going to be equal to MA times AG1, right? And here's a normal, we're basically adding a lot of equations, but they are very simple, right? We know, if you sum the forces in the vertical direction, we know N will be equal to MAG, right? How about on block B? What do you get on block B? So summing the forces in let's do it in a downward direction on B, you are going to get what? So MBG minus 2T is going to be equal to MB
half
AG1 over 2, right? And what? Okay, how do you go from here? So we can actually get the tension, right? Okay, so we can look at that equation. Okay, 1, 2, and then 3. Equation 1 and 3, how many unknowns do I have here? I have 2 equations, but I have 3 unknowns. Okay, T, F, right? T, F, and then I have AG. Okay, basically I need kind of one more equation here. And what do you think that equation that I will need to be able to solve, 1 and 3?
المومنت بالاول واحده.
Exactly, just get the moments here, right? So summing the moments about, let's call this guy point O, right? If we sum the moments about O, what do we get? We're gonna say that T times R, T times R is gonna be equal to what? MA is gonna be equal to MA times AG1 times R plus IG alpha 1, right? So هيدي الفورس equations. So هلا هون 1, 3, and then 4 are basically 3 equations, and they have how many unknowns? They have 3 unknowns, right? Which is alpha T and the value for the friction force. هلا so we can solve for the value for the friction force. Right? Okay, so how are we gonna basically do that? So let me actually rewrite that. So there is actually a, I'm sorry guys, so the force equation we have actually introduced alpha, okay? So هلا هون we've actually introduced one more unknown. So right, so هلا we have alpha, AG, and then T, and then the friction. So هون obviously, so when you have, every time you have this equation, we know we have a quick shortcut by saying AG1 is equal to alpha 1 times R, okay? And then we can get the tension directly in terms of the angular acceleration of the cylinder. So let me redo that. So from 4, I'm going to end up with what? So TR is going to be equal to MA, right? AG, which is equal to alpha, now R squared plus IG alpha 1, right? So MA R squared plus IG times alpha 1. Okay, so now we have our angular acceleration, and I can actually relate that back to AG over. So T R is going to be equal to MA R squared plus RG, and this is actually equal to, let's keep it AG1 over R. So T is equal to MA R squared plus IG multiplied by AG1 over R squared. So now we got the tension in terms of these values. Now from, okay, so now we have this guy, right? So from 3, we can directly actually get, from 3 we can directly actually solve for the acceleration of G1. This equation doesn't have the friction, right? So now we are here. So the idea here, one way to actually simplify this is if you sum the moments about point O, right? And summing the moments about point O will basically eliminate the friction. So directly you can relate T with AG, right? So that would be like a quick shortcut, right? If you sum the moments about that point, T times R will give you directly T in terms of AG. And I know AG can be related to alpha R, so the tension directly can be related to the acceleration of this guy, right? And now from this equation and then from T, basically I had what? So MBG minus 2T is equal to MB AG1 over 2, and I know the value for T from here. So MBG minus 2 times T, which is MA R squared plus IG AG1 divided by R. Right, so let me just 2 times T MA R squared plus IG divided by R multiplied by, right, 2 times T, okay, R squared is equal to MB AG1 over 2. And you can see from here, basically, now we have a value for the acceleration of G1. So don't worry, guys. On the exam, I won't give you something, you know, that involves that much computation. It will be basically, you know, like a little bit more simpler than what you are seeing here. Okay, so here we have directly solved for MBG divided by MB over 2 plus 2 . Okay, so there you go, guys. So here we have solved for the acceleration of G1. Next step is to calculate what? Next step is to calculate the friction, right? And how do I calculate the friction? I can directly use equation 1. Okay, the friction is going to be equal to T minus MA times AG1, right? And I know all of these guys, I can basically get the friction here. And at this point here, it would, let me quickly do that. So the friction is going to be equal to T minus, sorry, MA AG1. So the friction is going to be equal to the tension, which was equal to MA R squared plus IG divided by R squared multiplied by AG1 minus MA AG1. And I knew I just solved for AG1, I can get that friction. And they ask you for the smallest coefficient of friction, okay, coefficient of static friction. So we knew for AG to be equal to, or AG1 to be equal to alpha R, for this guy to be valid, right, we have to be, what, the value for the friction has to be less than mu s times n, okay? And the maximum has to be basically less or equal, right? So we're going, you know, we need to find that smallest coefficient of friction, okay? So the smallest coefficient of friction, right, is gonna be equal to, so the smallest coefficient of friction here basically is going to be equal to whatever. So after you solve for that value for the friction, right? So once you let go of the system, ultimately you are going to have that friction force, okay? AG1 is constant and then AG1 is constant here. Basically you can solve for F. F is there, is constant. So you are going to get F over N or F over M times G, okay? And then F is from here and then mg is known. So that would be the smallest coefficient. If mu s is less than that, when you try to evaluate this relationship, basically what will actually happen, you're going to get f to be greater than this, okay? And in that case, it means that this guy is slipping and then all these equations don't apply, right? So that would be the smallest value for your static coefficient of friction. Okay, guys, so we have under a minute left, so I'm going to close this and then reopen it one last time, and then I'm going to answer any questions that you guys will have regarding this, questions on the final